Hi, welcome back. Today we will talk about current and voltage control in ring oscillators. So let us define or draw how a typical ring oscillator looks like. We will use a 5 inverter based ring oscillator as an example to understand how this works. So this is a typical oscillator, and when you have a current control for each of these inverters, it becomes a current controlled ring oscillator. So, and while doing this, if you would like to understand that you want to have a selective current control, then you could typically add a list of switches here. So each of these switches can act as power gating systems to understand what is the various currents that can flow through each of the inverter and what is going to be the output frequency. Now here you will have the current control, which I would call it as IVCO, and this would be the power supply VDD. So this is the current control behavior. Now in this case, in this implementation, if there is a bias voltage for each of these current source, and this bias is typically given at the gate of the current control, it becomes a voltage control here. So in effect, though it is a voltage controlled, it is basically the amount of current that is flowing through each of these inverter which is designed. Now, how do you implement this particular structure? So in this particular case, you would use what is called a current starved inverter. Current starved inverter. And the way it looks like, you can have two kinds of current starved inverters. One, in this particular case, there is a, since it is there above the inverter, it could possibly be a PMOS device followed by an inductive inverter structure with both PMOS and NMOS present. So this becomes the inverter and this becomes the V control point. So you would have 5 such devices where you can control it, and that would be your simple current starved inverter given in a loop. And there will be a closed loop present here. So this is a good current starved inverter, and this is how you would do a voltage and a current control. Now what this would do is it would starve the amount of current. Current gets starved due to the VDS loss or the headroom that gets lost due to adding of this particular stack of PMOS devices. So this will reduce the total amount of current that can go into the system. Now this also limits what is your maximum frequency, because and what is going to be the swing that you will get. So current start inverters have these two challenges, that they will be swing limited. That means the maximum swing that their inverter structures can go through will not be rail to rail. It will be limited to what is the maximum drain drop that is seen due to the current control system here. Now that you have understood how current and voltage control is given, now let us see how you can use different frequencies to be generated from a single ring oscillator, and that is by using different current loads that you can, or current control that you can have in a VCO. So let this be your VCO, right? And this VCO will have its own current control. So you find out what is the amount of current that is flowing through. It will have its own switching network to turn on and turn off the amount of currents that you need. In this particular case, as an example, I am going to use 5 current sources. Each of the current sources is going to be binary weighted or thermometric weighted current source. And the way the connection is going to be given is the center line will have the always on current source. That means you will have the smallest value present over here, which we will call it current as I. Then we will keep the next nearest one to be another I, such that we can have 2I current source, and the adjacent one will be 2I. So now if you turn on all four of these together, you get 4I, or just 2I plus 1I, you get 3I. In this particular case, you would have 4I, and the far end you would have 8I. So with this proper selection of the switches that are present here, you can choose different current ranges. And we know that in a particular VCO, which is operated with a ring oscillator, there are two factors. One, the frequency output of the VCO is directly proportional to the bias current through the inverters. Second, the frequency is directly proportional to the supply voltage VDD. So now if you want to have a multi-band VCO output, then you can use this kind of a architecture to discuss about control. Now, for example, if you want to design a 0.5 gigahertz output VCO, just selecting current I would suffice. Now, suppose if you want a 2 gigahertz current, you could probably use I plus 2I, and this 3I current will give you a 2 gigahertz band. Next, if you want to have, say, 5 gigahertz, right, it might come out to be, say, 4I plus I. I'm just using an example. So about 5I of current will give you 5 gigahertz. And if you want to end up with, say, 8 gigahertz, you would probably utilize, say, 4I plus 2I plus 1I. And say you want finally a 10 gigahertz value, you could use the 8I plus 4I, giving example. So you would have a multi-band. So you can have like this 2, 3 or multiple bands of frequencies that you can target having a current controlled or a voltage controlled ring oscillator. Now this kind of a topology is very frequently used in wireline and wireless systems. For example, if you would use say you would use a technology or a protocol called USB 3.1 and 3.2 or 2.0 and 3.1, you know that the frequencies needed by both these, for example, the 2.0, it could be working at, say, an example 2.5 gigahertz, and the USB 3.1 might be working at 5.0 gigahertz. Now, in such a case, you can use a single VCO, right? You can use a single VCO, which can be your voltage controlled, right, present within a single PLL loop. Now, this benefit will allow you to do a wide range of current control, and this also allows you a much wide frequency operation. So the form factor is good, the tunability is good. What is the only drawback? One of the biggest drawbacks for using this very much is going to be your PLL phase noise or the jitter, which is going to be slightly larger compared to any other LC-PLL based implementation. I hope you have understood how current and voltage control happens in ring oscillators and how you can perform a wide frequency operation.